All right, good evening once again, students. We're here for another class, another session. Our topic today is factorization. So you would have recalled that we have the previous lesson was on removing brackets. Now, when we were dealing with brackets, we were actually multiplying out what is in the brackets by what is outside. Now, when we do that, we're actually finding a product. Now you multiply one thing by the other, the result that you get is the product. Now, when we actually find the product, let's say that we are multiplying 6 times 2, then the product would be, what would be the product? If you're multiplying 6 times 2, the product would be what?
12.
12, right. So if the product is 12, then now if you recall from the earlier times when we were defining what a product is, right, we say that the product is the result obtained by multiplying 2 or more numbers. All right, now, if you think in terms of the numbers that are being multiplied to get the product, what do we call those?
Factors, sir.
Factors. Good. So the factors then are the things that are being multiplied. Now, for algebra, if you're multiplying 2 terms together, like say 2 unknowns, x and y, then those would be factors, but the result would be xy. So x times y would be the factors, the result would be xy. But if we're thinking now in terms of brackets, if we are multiplying a term outside the bracket by the bracket itself, when we remove the bracket, what we get would be the product. Now, what we multiply together would be the factors. So let's say that we have 3 bracket x plus y, right? Now, when we multiply out those, we will get 3x plus 3y. That would be what? The product. Do you agree? Or do you want to see what I'm saying? All right, so let me just write the demonstration here. All right, so let's say that we have 3 times bracket x plus y. When we multiply out this bracket, we do so using the distributive law.
3x plus 3y.
So what we would get would be
3x plus 3y.
3x plus 3y. All agree? Let me see the answer.
Yes, sir.
Who agree with what I'm saying?
Yes, sir.
Okay, let me see the hands of the others who agree with what I'm saying. All right, good. Now, what would be the factors? Now, the product is actually 3x plus 3y. What would be the factors?
3x and y, sir.
No, those are not the factors. 3x plus 3y would be the product. Remember, this is an expression. And the expression remains as is because we cannot simplify them by adding them. Right? but we get this expression as a result of multiplying what? What did we multiply to get this?
3 and the bracket x plus y.
Correct, Miss Cox. So we get this as a result. This is our product. But we get this as a result of multiplying 3 bracket x plus y. Now, remember what we say. The result that we get would be the product, but the numbers that we multiply together to get the product, what we call those?
Factors.
Factors. So what would be the factors here that give us this product? What would
Sir, 3 and x plus y.
correct? Because remember that you're multiplying the 3 times the bracket. So the 3 is a factor and the bracket is another factor. Is that clear to everybody? Is that clear, students?
Yes, sir.
All right. And so that's what we have been doing. And so in one case, we multiplied by a single term, and we do so distributively. In the second case, we look at binomial products where we have 2 brackets multiplying together. That's what we did previously. And so when we expand these brackets, what we get is the result in the expanded form, which we would refer to as the product. All right, let me clear this. All right, so moving along now. All right, so our topic here is factorization. And what we'll be looking at through this topic, we'll be looking at how you should be able to list the different types of factorization technique. You should be able to determine the HCF for a set of algebraic terms. You should be able to factorize expression by the HCF technique. You should also be able to factorize 4-term expression by grouping, as well as you should be able to factorize quadratic equation. Now, before we get now into the factorization technique, I want to go back to what I was saying. Now we say, previously we look at multiplying brackets by a term. So 3 brackets x plus y. When we expand that, we get 3x plus 3y. Now, so the factors here would be 3 and x plus y. So the bracket is treated as a single unit. All right, now, if this is our product, when we expand or when we remove the brackets, factorization then is working in the reverse order, right? So when we remove the bracket, we get the product. But what factorization does is if you give the product, if you get the product, if you get the 3x plus y, you should be able to write it back as factors. Or you should be able to write it back as the product of factors. Now, that process of writing back an expanded expression back to factors is what we're referring to as factorization. Let me see if you understand what I'm saying, guys. All right, so in other words then, most often you'll be given an expression. So let's say that you are given 3x so you're given 3x plus 3y. Now, if you were asked to factorize 3x plus 3y, what it means, we have to write it back as this, right? Now, how can we get from this back to this, right? So we have to do so by the techniques of factorization. Now, for instance, this one, if we are factorizing, meaning that we look at each term in the expression and we look to see if there is a common factor. You look at these terms, do you see any factors or a factor which is common? What is common?
3, sir.
3.
3.
Right. So the 3 here is a common factor. So what we generally do when we're factorizing, we search for the common factor. And this is for just one technique based on the expression. You search for the common factor. You pull out that common factor from the expression. You write it. Then you open your brackets. Then the same 3 that you pull out, you use it to divide each of the terms that are in the expression. So in other words, the 3x, you divide it by 3. So if you divide 3x by 3, the 3 cancels out. You're left with x. So you put x in this bracket. If you divide the 3y by 3, 3 cancels out again. You're left with y. Keeping the plus sign between them, so you will get x plus y, and then you close your brackets. So what this what would this result in would be the factors of this expression, and so the factors would be 3 and the brackets. So the process of getting from here to here is what we refer to as factorization. And as the name suggests, we're making factors from the expressions. That's why it is called factorization. Is that clear, guys? Let me see the hand if you understand exactly what I'm saying. If it's not very clear to you, I can review it again. So please, I want you to get that concept clearly now, because this concept is this concept that we are going to be using throughout this topic. And so you have to
again, sir.
You have to understand. Who was that? Who was that just now?
Miss Green.
Okay. So you have to understand that what we are doing when we're saying we're factorization, we're making an expression, we're writing it back so that we have brackets and numbers or whatever in it to multiply each other. So to factorize, it means that, for instance, let me give you in a very trivial way. So let's say that we have 12. And 12 is a number, and I say factorize 12. Now, it means that to factorize 12, you need to find 2 factors of 12 that multiply to give you 12. So what would those numbers be? Well, it can be 6 and 2. 6 times 2. It can be 3 times 4. etc. So these here are factors of 12, but we write them in such a form that when you factorize, it means that the factors, when you multiply them, you should get back the product. Right? 6 2 is 12. So this is what you started off with, and you get this. Now, previously, when we were removing bracket, we started off with the factors and we multiply out the brackets, right? And so we will get the product. So just to recap what we are doing, is that reviewing from the previous topic. Our previous topic was what? Brackets. And what you were given something like this, and you're asked to remove the brackets. Now, in order to remove the bracket, you take what is outside, you multiply what is inside, and you get this. When you remove the bracket, you're really, what you're doing here when you remove the bracket, you're really multiplying out the bracket with the what is outside. So in other words, you're finding the product. So multiplying what is inside the bracket by what is outside give you this. So that would be the product from multiplying the 3 times the brackets. Now, if you remove the brackets, you get an expression. So what you're saying now, if you reverse this process, given an expression, can we get back brackets or can we get back factors? Yes. So we can get back the factors by starting with the expression. So this is the expression that we get as the product. To get back the bracket, what we do, we look at the terms in that expression, identify common factors, pull out the common factors, 3, and then now we open brackets. So we take out the common factors, open brackets, divide each term by the common factor that we take out. So we divide 3x by 3, cancels. What we get here, we put in the bracket. So I have x remaining, we put that in the bracket. Divide the next term, which is 3y, by the same factor that you pull out. And you see the factor cancel, you're left with y. So we put y in the brackets. So what I've just done was to factorize this to give back this. So this process that I've just carried out, working with this expression, finding the common factor, dividing each term and putting the results in the bracket, that is the process of factorization. Is that clear now, Ms. Green?
Yes, sir.
Right, so this topic is all about doing that. It's all about getting expression and writing them back in bracketed forms. And that process is what we call factorization. But I'm trying to give you a sense, based on what you know about factors, that factors are numbers, or in this case, terms that are being multiplied together. So those are what factors are. So if we are given an expression, to factorize it, we want to write them back in terms of things that we are multiplying together. All right. Any question before I continue? Let me see the hands of those who may have questions. All right, so is that clear to everybody? Let me see, and if it is clear, guys, we can move forward. All right, so now let us jump into this topic to understand a little bit more about factorization. Now, from bracket, we would have looked at how to remove a bracket with a single term outside, and we use the distributive property to remove the brackets. We also look at 2 brackets, right? If we can recall, you may have a bracket like x plus some number, say 2 times x plus 3. All right. All right. So for this situation, if we remove this bracket, let us see what happened. We would take the first term in the bracket and multiply each term in the second bracket. So x times x will give you x squared. And then x times 3, that will give you 3x. And then 2 times x. So this 2 times this x will give you 2x. Two times this 3 give you 6. I'll put down 6. When we simplify this expression, we add the like terms in the middle. So we get what? X squared plus, so we add 3x plus 2x, we get 5x plus 6. Now, this is the product of these two brackets, but it means that the one bracket is a factor times the other bracket, which is another factor. Now, it means that we can be given this expression and we are asked to factorize it. Now, when we factorize this, we should get back this. So it means that we have to reverse this process in order to come back from here to here. All right. Now, this expression here, we refer to this expression as a quadratic expression. I'll talk a little bit more on that when we move further on. But I just want you to understand that what we have been doing, removing brackets, factorization is the reversal, we're putting back brackets, right? And that's what we're doing here. Now, factorization is not as straightforward as removing brackets. Why it is not as straightforward? Because just as I showed you just now, you can have different kinds of expression. Now, each of these expressions may require a different technique, meaning we don't have just one technique to factorize it based on the type of expression. So first you have to learn how to identify what expressions you have to know which technique to apply. So that's the first step in learning how to factorize. First, you become familiar with the expressions and know what the technique that you're going to use. Because if you are not able to do that, you're going to be lost. And so we're going to be looking at now the types of factorization techniques. And then now we'll move along and then you'll see the types of expression that these techniques are applied to. All right, so the techniques that we have factorization by common factors. Now, the common factor is referred to as the highest common factor, meaning that it's not just any common factor, but we're looking for the highest one. All right, so we call this one the HCF method, the highest common factor method. This is the first technique. All right, the next technique, you will also still apply HCF method, but now you would apply it in a grouping situation, right? So you have a situation which is not grouping, which is HCF. You have another situation where you can group with the HCF, right? So it means then when we're dealing with grouping, we generally have to find pairs of common factors that have pairs of terms rather that have common factors. And oftentimes this technique is used when we have short-term expressions. All right. The first technique is used. First technique is used when you have just common factors. So it doesn't matter how many terms in the expression, but once you have common factor only, you search for those common factors, you pull them out, you divide each term in the brackets, and you put back whatever you get. You divide each term in the expression, and you put back whatever you get in the brackets. The grouping method generally applies to 4 terms. So for the 4 terms, you have 2 pairs that have common factor. We look at those. Now, the next method is when we have quadratic expressions. Now, quadratic expression has to do with the last, when we look at the removal of 2 brackets, when we multiply 2 brackets together, which we call a binomial product, we will get an expression which is a 3-term expression, generally referred to as a trinomial expression. We have to use what we call the AC method. Now, the AC method is not the only method for the quadratic, but is the method that is commonly used. Now, after you have mastered this method, which is the AC method, I will also show you an alternative method that you can use instead of the AC. All right. Now, we have some expressions that we call perfect squares. Now, perfect squares, we have, because this is a special type of expression, there's a certain method that we can apply to it. Now, perfect squares can also be factorized by grouping, or by, in some case, depends on it, it can be factorized by quadratic method. Perfect squares can be factorized by quadratic method, but because the perfect square has a certain feature, we can just inspect. So we inspect what the characteristic feature of the perfect square is, and then from that we can just pull out what we have as a factor. Now, all of this would have to be demonstrated for you to understand what I'm saying. So I'm just telling you now the different types of techniques that we have. So we have another expression that we call difference of squares, or difference of 2 squares. And this one is also, it has a particular technique which comes with a formula. And so when we are factorizing this, we will apply that formula. So once we identify the expressions of difference of two squares, then we'll use that formula. Now we have some expressions that consisting of 5 terms. Now for these expressions, we will have kind of an integration of probably 2 or more of the methods above. So depending on what or how the expression appears, we can use probably a quadratic method along with a HCF method or so on. And so we'll see how that works, all right? So far, what we really have here, we have 6 different techniques, and each technique applied to a particular expression, right? So it means that first you have to identify the expression to know which of these techniques to apply. So in other words, you can't look at every expression and try to use one method to do it, because one method doesn't work for all. Depends on the expression, it will have a particular technique. So I want you to focus in that way, that first you need to identify what expression you have, then apply the appropriate technique. All right, so the first thing we're going to look at is the HCF technique. And so when you have expressions that have all the terms. And remember, I said all the terms. If all the terms, you can identify a common factor, right? It means that it can be factorized by the HCF technique. So first, I look to see if in all the terms in the expression, if there's a number that occurs in all the terms, like say we have 3x plus 3y, 3 would be common. If there's a letter that occurs in all the terms, let's say that we have AB plus AC, then A would be common, then those would be the common factors. And so those are what we have to pull out when we are factorizing by HCF method. Now, definition here, if two or more terms have factors which are the same, these are called common factor. In this case, to factorize, we note the highest common factor to all terms in the expression. And I want to make the emphasis. When we say common, it needs to be common to all terms, not just two terms out of the expression, but all the terms in the expression must have the common factor in order for you to use that factor to factorize. All right. Now, we have to choose in terms of highest common factor, because even though you might pick out a factor that seems to be common, it might not be the highest common factor, especially when you're working the common factors with numbers. All right, so give me a second, guy. All right, so moving along. All right, so when we're dealing with the HCF method, these are the steps that you first going to follow. So step one. Well, step one, you should identify a common factor, right? And once you identify the common factor, you're going to position the common factor. Then you're going to open brackets, right? Now, step two, when you open your brackets, now the terms from where you get the common factor, you're going to divide each term in the expression by the common factor. And whatever you get as a result, you're going to put those results in the brackets. All right. After you find all the results, you're going to keep the plus and minus signs that you have in the original expression. Unless you are factorizing with a negative, the signs will be the same as what they were in the expression. If you're factorizing with a negative, the sign is going to change to their opposite. All right. So now keep the plus and or minus signs from what we divided. Now, once you have done that, then you simply close the bracket. Once you have divided all of them and put all of those results in the bracket, you simply close the bracket, and then that will be the end of that factorization process. So HCF techniques really involve 4 steps. So just to recap the steps, first, you identify your common factor, you place it in position, then you open brackets. Then after you open brackets, then you go back to the expression and divide each term in the expression by the common factor. The result you get from dividing, you put them in the brackets, maintaining the same signs, the plus or minus signs from the expression in the bracket, and then you close the bracket. Pretty straightforward. Now, looking at these examples. Now, here, let us look at example 1. We first need to find our common factor. And here, when we look at 2x plus 6, what factor would be able to go into 2x and to go into 6? Which factor can go into 2x and 6? Which number can divide 2x and 6?
2, sir.
2, sir.
Right. So your 2 here would be a common factor because it can divide 2x and it can divide 6. Now, is that the highest number that can divide 2 and 6?
Yes, sir.
Right. So in that case, 2 here is our highest common factor. So you position your 2 here. So you position your 2. So that's the HCF. Once you place your HCF, then you open your brackets. Then what you're going to do next now? Let me see if you are following. What we're going to do next? Go ahead, Mr.
2 into 2 would go 1, sir. So you leave with just, and the x there, it doesn't make sense writing back 1x in the bracket, so you just put x.
All right. So what I would rather you're saying, Ms. Ways, not 2 into 2, but 2 into 2x, because 2x is a number, so to speak, and you're dividing it by 2. So each term, they're dividing it by 2. But I understand what you're saying. When you divide 2x by 2, the 2 cancel out and you only have x remaining. So if you divide this by 2, 2 cancel, you're left with x. You put the x inside here. Now, the next step now is to keep the sign from the expression in the bracket. And then now you divide the next term now by 2. So we'll divide what? Divide the 6 by 2. 2 into 2, we get 1. 2 into 6, we get 3. So here now we would put 3 in the brackets after we finish dividing that term. And then we close our bracket. So pretty much when we factorize 2x plus 6, the factors are 2x, bracket, x plus 3. These are the factors. Is that clear, guys? Let me see your hands if you are clear.